In this video, we're going to go through some percent yield practice, numbers 1, 4, and 7 from the worksheet. So number 1 says, using the Hoffman apparatus for electrolysis, a chemist decomposes 36 grams of water into its gaseous elements. How many grams of hydrogen gas should she get theoretical yield? So we're looking for the theoretical yield. The first thing we always need to do is balance the equation. So water is decomposing, so we're going to have our arrow there, into oxygen and hydrogen gas. Notice we have 2 hydrogens on both sides of the equation, but only 1 oxygen as our reactant. So we need to put a 2 there to make our oxygens balanced. Now we have 4 hydrogens, so we need a 2 here as well. Now we're balanced, so notice the O2 is blank, and that means that there's really a 1 there as the coefficient. We need 1 O2 molecule, or we'll produce 1 O2 molecule from this. So now we're ready for step 2. We need to identify our given and our unknown. We are given 36 grams of water. Okay, so this is our given. And we are looking for the grams of hydrogen gas. So this is our unknown, our hydrogen gas. So let's start filling in our BCA table. So before, when we start, we have 36 grams of water. Remember, our BCA table only can have moles. So I'm going to convert our 36 grams of water into moles of water by using the molar mass of water. And that's from the periodic table. So this will give us our moles of water. And since 36 is 2 significant figures, I'm going to round to 2 significant figures. So we really have 2.0 grams of water. So that's what we're starting with. Oh, I'm sorry. This is not grams. Notice our grams cancel out. We're left with moles. So we have this many moles of water, about 2 moles of water. So before, we start with 2 moles of water. And since oxygen and hydrogen gas are being produced, we're going to start with 0 moles of each of those. Now we're ready for our change. Since H2O is the reactant, it is all going to react. So it's going to be minus 2C. The 2 comes from the coefficient. We don't really care about oxygen because that's not a part of the problem. And since hydrogen gas is produced, we're going to add 2C. That 2 again comes from that coefficient. So we're losing our reactant, H2O, and it is becoming our product, H2, and oxygen gas, of course, but again, we're only looking for the grams of hydrogen gas. So, after the reaction takes place, we're going to be left with 0 moles of water. It's all going to decompose, and it will be 0 plus 2C moles of hydrogen gas. So, looking at our water, I want you to notice right now we have 2 minus 2C equals 0. So when we solve this equation for C, it would be 2 equals 2C, so C would equal 1. We divide both sides by 2. And so now we can plug in our C as 1 into our equation for the moles of hydrogen gas. So 0 plus 2 times 1 would give us 2 moles of hydrogen gas. But we want grams of hydrogen gas. So we're going to take our 2 moles of H2, and in order to convert it into grams, we are just going to use the molar mass of hydrogen gas. Since we're going to grams, the molar mass of hydrogen gas goes on top, and that's the amount of grams in 1 mole of hydrogen gas. So when we multiply this across, and remember we have 2 significant figures at this point, because that's what we were starting with, 2 significant figures. So we'll have 4.0 grams of hydrogen gas. So that is our answer. That is our theoretical yield. Number 4 says, suppose 4.61 grams of zinc was allowed to react with hydrochloric acid to produce zinc chloride and hydrogen gas. How much zinc chloride should you get? So again, we're trying to find the theoretical yield. Again, our first step is to balance the equation. Notice this time you're not even given the equation, but we are told that zinc was allowed to react with hydrochloric acid. So zinc is reacting with hydrochloric acid to produce, so it's going to produce zinc chloride and hydrogen gas. Now we need to balance this equation. Notice we have 1 zinc on both sides of the equation, 1 hydrogen and 1 chlorine as the reactant, and 2 chlorine and 2 hydrogen in the product. So I'm going to put a 2 here. Now I have 2 hydrogen and 2 chlorine in the reactant and as the product, and everything is balanced. Step 2 is to identify what we're given and what we're looking for. So we're told we have 4.61 grams of zinc and it reacts with that hydrochloric acid. Since we're not told the amount of hydrochloric acid, we're going to assume that we just have a bunch of hydrochloric acid and it doesn't really affect the reaction. It won't affect our calculations. And we want to know how much zinc, so how much zinc chloride should you get, which is the theoretical yield. So we're really looking for the grams. Whenever it's theoretical yield, it's really the grams or the mass of zinc chloride. So now we're ready to create our BCA table. And again, we're going to ignore the hydrochloric acid because we're not told anything about its amount. We're going to assume that we just have extra hydrochloric acid. It doesn't affect our calculations. And we can ignore the H2 because we're really just looking for how much zinc chloride was produced from our given amount of zinc. Remember, our BCA table only concerns moles. We can only put moles there. So we're going to convert our zinc into moles, our grams of zinc into moles of zinc. When we do this calculation and divide by the molar mass, we get 0.0705 moles of zinc. Notice we have 3 significant figures that we're starting with, and so we want to end with 3 significant figures. Leading zeros, the zeros in front of the 7 don't count as significant figures, so the 705 are 3 significant figures. So we'll start with 0.705 moles of zinc, and that is our reactant. So we're going to start with 0 moles of our product because nothing, before the reaction hasn't even happened yet. So we haven't produced anything. And now for our change, notice our mole ratio is 1:1. So we'll have minus C or minus 1C. Because we're changing zinc by its mole ratio, and then we'll have plus C or plus 1C because zinc chloride is going to gain that amount. And then after, so our reactant will be 0 now, and our product will be 0 plus C. So we need 0.705 minus C to equal 0, so that would make C 0.705 as well, because 0.705 minus 0.705 gives us 0, so we'll plug that in here, and notice we form 0 plus 0.705 moles of zinc chloride, so we really have 0.705 moles of zinc chloride. But we need to know the theoretical yield, so we need to know the grams of zinc chloride. So we're going to cancel out moles by multiplying by our molar mass, which you can find from the periodic table. So we have produced 9.61 grams of zinc chloride. This is our theoretical yield. So theoretically, this much should be produced. The second part of this problem said, suppose that you actually recovered 8.56 grams of zinc chloride. What is your percent yield? So we're looking for percent yield when we're given 8.56 grams of zinc chloride as our actual yield. So now we have our theoretical yield and our actual yield, so we can use our percent yield equation of actual yield divided by theoretical yield times 100 to get our final answer. And so when you do this calculation, it should be 89.1%. So I want you to pause the video and try number 7 on your own, and then I'm going to show the work in a minute. When you balance the equation, hopefully you get this. If you didn't, please double check your work. Go ahead and pause the video, and the next step will be to annotate the problem. So in this problem, we're looking for two things, the mass of carbon dioxide and the percent yield. We are given two things, the grams of oxygen, the mass of oxygen, and the actual amount, so our actual yield of carbon dioxide. Try and create a BCA table and then check your table with mine. Pause the video. Hopefully you got this as your before part because you converted the grams of oxygen into the moles of oxygen. Pause the video for the change part. Hopefully you got this for your change part because of the mole ratio of 2 to 1 of oxygen to carbon dioxide. Pause the video for the after part. And this should be your after because our reactant reacts, so we're left with 0 oxygen, and then 0 plus C for our carbon dioxide. Go ahead and solve for C and solve the rest of this problem. So theoretically, we could produce 8.01 grams. So this is our theoretical yield. As you can see, my change was 0.182 moles, which means that my total amount of carbon dioxide formed, 0 plus my change, is equal to 0.182 moles, and then I converted that into grams. Now I need to find my percent yield by doing my actual yield over my theoretical yield times 100. And there is my percent yield. Notice my actual yield was given from the problem, that's from right there, and then my theoretical yield is what I just calculated, the 8.01.